I am the student of SY Mechanical at Anna Sahib College of Engineering and Technology, Ashta. Today I am presenting the ISE activity on the topic Dynamics of Motion on the basis of stability of four-wheeler when taking turn. Introduction. Four-wheeler stability in the road depends on the maintaining positive ground reaction forces on all wheels to prevent overturning, heavily influenced by centrifugal forces and gyroscopic couple. A high center of gravity, high speed or sharp turn reduces stability and the centrifugal force tends to lift the inner wheels. As the figure is shown in here, the figure shows that the vehicle is taking left turn, then the wheels A and C becomes inner wheels of the vehicles and wheel B and D are the outer wheel of the vehicle. Then the centrifugal force, centrifugal gravity which will act on the center from the lies vertically above the ground surface. There are this is the axis diagram of this point. Here is a three axis. First one is the axis of spin in which the component will be rotated. Other is axis of precision and third one is axis of gyroscopic couple. Here is the nomenclature of the diagram. First one is the M. M is the mass of the whole vehicle. A is the track width. L is the length base. H is the height from center of gravity from the ground surface. Then MW is the mass of each wheel. IW is the moment of inertia which is acting on the wheel. Then ME is the mass of engine and flywheels. Then MW is the mass of wheel. Omega E is the angular velocity of engine rotating parts. Omega W is the angular velocity of wheel. R is the radius curvature being navigated. V is the linear velocity in meter per second, that is RW into omega W. The center of gravity of the vehicle vertically above the ground surface. Here is the later consideration as the vehicle having mass W which is equally constructed over the four wheels. Then the equation becomes R1 is equals to R2 is equals to R3 is equals to R4 is equals to omega W by 4, in which the whole mass of the vehicle which is equally constructed over the four wheels, that is mg divided by 4. Then the effect of gyroscopic couple. As we know that the vehicle taking left turn because of engine rotating parts and precision, there will be gyroscopic couple will be act on the vehicle, which is velocity of precision is omega p is equals to v divided by r. As we know that equation of gyroscopic couple C is equals to I into omega w into omega p. Here we consider the four wheels, so the equation is multiplied by 4. Then the gyroscopic couple due to engine rotating parts is CE is equals to I into omega p. Then we simplify the equation. Then the equation becomes CE is equals to IE into G into omega W into omega P. Therefore, the value of omega E is equals to G into omega W. The net gyroscopic couple acting on the wheel is addition of gyroscopic couple which is act on the four wheels and the addition of gyroscopic couple due to engine rotating parts. Then the equation becomes net gyroscopic couple is equal to C is equal to CW plus minus CE. We take plus minus as we know that when we take positive sign when the engine rotating parts and wheels are moved in the same direction, and negative sign in which the wheel and engine rotating parts are moved in an opposite direction. Then the total equation net gyroscopic couple will be act on the vehicle, which is equal to C is equals to 4 into IW into omega P into omega W plus minus I into G into omega W into omega P. This is the net gyroscopic couple will be act on the vehicle. Then the as gyroscopic couple act on the vehicle, then the reaction on the road surface will be produced. Vertically reaction will be produced. The vertically upward reaction will be produced on the outer wheels, and vertically downward reaction will be act on the inner wheels. Then in the form of reaction which is denoted by P, as C is equals to P into A, therefore C is divided by A. Vertical reaction on each the outer and inner wheels becomes P by 2 is equals to C divided by C by 2 into A. Then the centrifugal couple will be act as well as the centrifugal couple will be act on the vehicle. Vertical moves along a curved path, therefore centrifugal forces will be actually act on the center of the gravity of the vehicle. The effect of centrifugal force is also overturn the vehicle from the center. Then as we know, centrifugal force equation F is equal to mv square divided by r. The couple to overturn the vehicles from the overturning couple CO is equals to F C into H is equals to mv square divided by r into H. The couple taking the overturning of vehicle, then CO is equals to FC into H, as we know that from previous slide. This overturning couple is balanced vertical reaction which are vertically upward on the outer wheels and vertically downwards on the inner wheels. The magnitude of the reaction at the two wheels on the inner side is Q. Q into A is equals to CW. As we simplify, Q is equals to CW divided by A, mv square into H divided by R into A. The vertical reaction on each outer and inner wheels is becomes Q by 2 is equals to mv square into H divided by 2 into R into A. Then the total reaction on each wheels becomes first the inner wheels which is denoted by R1 and R2. The vertical reaction on these wheels becomes mg divided by 4 minus p by 2 minus q by 2. This is the final equation for the inner wheels, and for outer wheels which is denoted by R3 and R4, the equation becomes mg by 4 plus p by 2 plus q by 2. These are the equations which is effects and going act on the vehicle while taking the left turn. Thank you.